Hi Pre-Calc, this is still 4.1. We're going to talk about how to convert between degrees and radians, and so going from degrees to radians or radians to degrees, either way. It's similar to, I believe it's called dimensional analysis in chemistry when you're converting units, okay? Same concept. I'll just keep it basic just so you get it, but the general idea, it's in your book on page 263. The general idea is if you're trying to go from degrees to radians, you want to multiply by pi radian over 180. If you're trying to go from radians to degrees, you want to multiply by 180 over pi. So whatever you're trying to get rid of, you want that unit on the bottom. So if you're trying to get rid of degrees, you want to have the degree cancel in the bottom. If you want to get rid of radians, you want the radian to cancel in the bottom, right? So it goes away. So the idea is, like, for instance, if I have 60 degrees, I want to put the degrees in the bottom so that it goes away. So there's the 180. And pi is equivalent to 180 in terms of magnitude or length, okay? So then the unit of the degrees cancel, and then we can divide 60 by 180 is 3, so this is equivalent to pi over 3. So 60 degrees is the same thing as pi over 3. Likewise, the idea is if you start with radians, okay, so I have pi over 4 radians. So now I want to multiply, I want to cancel out the radian unit. So now I want to put the pi on the bottom. Okay, and the 180 goes on top. So now the unit of radian is going to cancel. Let me just fix the lighting a little bit here. Now the unit of radian is going to cancel. The pi's happen to cancel. There can be some weird scenarios, but the pi's are going to cancel here, and then 4, let's see, goes into 16 and 20. 4 goes in 16 and then 20 is 45 degrees. So you're going to start, yeah, we're going to degrees. So you're going to get 45 degrees out of this one. All right, so those are the basic conversions from radians to degrees, okay? Let's also talk about how to convert 1 radian to degrees. So sometimes students will ask me, like, what is 1 radian in degrees? So I want to show you how you calculate this, okay? So if you have 1 radian, again, to cancel radians, you want to put radians on the bottom and degrees in the numerator, like this, so that the units cancel of radian. Now, this is actually a calculator problem. You're going to end up doing 100. You actually do the math on this. Let me make sure you guys can see this good. Okay, you can see it. All right, so you're going to actually do 180 divided by, I have a pi key. You should be able to have a pi key. You should have one in your calculator. So you can see that this is approximately 57 degrees. So if you ever wonder, like, what's 1 radian, it's approximately 57 degrees. Okay, let me see what else. All right, let me keep going with this. So complementary angles, if you have a complementary angle, it means that the 2 angles are going to add to 90 degrees if you're in degrees, or pi over 2 if you're in radians. If you have a supplementary angle, the 2 angles are going to add to 180 degrees. If you're in radians, they're going to add to pi, okay? So it just depends. Be consistent with the unit you're in. So, like, for instance, if I start with 10 degrees, then for a complementary angle, that means, that 10 degrees plus something has to equal to 90 degrees. So if I just do the math here, like I move the 10 to the other side, that means that the complementary angle is 80. All right, for the supplementary angle, that means that my 10 degrees plus x has to equal to 180. So if I do the math on this one, I move the 10 over, my x is going to be 170 degrees. Okay, so that's the complement and the supplement. By the way, not all angles have complements and supplements. Like, for instance, if my angle was 100, if I started with 100, there's no 2 values that are going to add to 90. So 100 doesn't have a complement, but 100 has a supplement of 80. Okay, so just be a little careful of that. So likewise, what I was just saying a moment ago is if you start with degrees, end with degrees on the test in the final, okay? If you start with radians, like let's say you started with, let's start with like pi over 4. So the complement would be pi over 4 plus x would equal to pi over 2, because the complement has to add to pi over 2. So then I would subtract pi over 4. Right, you're going to need an LCD here, so you're going to have to bump this up. That would end up being pi over 4. Okay, so the complement of pi over 4 is pi over 4. Now the supplement would mean that you have pi over 4 plus something is going to equal to pi. Likewise, you have to still solve for x here. You have to get an LCD, so you're going to have to multiply up down by 4 on this. So 4 pi over 4 minus pi over 4 is 3 pi over 4. So if you start with radians, you have to end in radians, right? If you start with radians, you have to end with radians. So for the complement of pi over 4 is pi over 4. The supplement of pi over 4 is 3 pi over 4. Now let me just see real quick if there's anything else I just want to stress. I may in the homework give you an area of a circle. That is just strictly putting in this formula. The only thing that gets tricky, students always do this right. They know how to put the half times the radius squared times theta. What they get confused is they miss this minor detail that in the formula, theta has to be in radians. So you can't use degrees here. You have to use your unit conversion to move it into radians and then plug that angle in. So I may ask you just one of these for area of a circle. An arc length is also very easy to calculate. There's the formula here. And again, you have to make sure that theta is in radians. Okay, so the formulas are really basic, but if your theta isn't in radians, you won't match the answer in the back of your book. All right, gang, that's it for 4-1. I'm going to move to the other sections. I'll catch you. Bye-bye.